Hi everyone, my name is Lydia and this is what I wish they taught me about econometrics and introduction. Two of the most commonly confused concepts in econometrics are omitted variable bias and multicollinearity. Both involve correlation between variables, but they are completely different problems with completely different consequences. And confusing these two in one being one of the most common mistakes in applied work and also dissertation workups. So hopefully this video will make that distinction more permanent for you. Let's start with what do they have in common? So both, and we're going to do OVB here and multicollinearity in here. OVB and multicollinearity, they both involve correlation between regressors. So same correlation between regressors. Okay. This is also the reason why students consistently confuse them. But what they do to your estimates is actually very different. And one makes your estimates completely wrong and the other makes them uncertain. When does omitted variable bias happen? Remember, we had two conditions for omitted variable bias to happen. And the first one was a relevant variable is omitted. And the second condition, remember, both of them had to be satisfied for omitted variable bias to happen, was that the omitted variable, and it is correlated with an included variable. The end result for this, because you were missing something very important, coefficient is biased. Okay? You are missing an important variable, the model is misspecified, and the estimate you get is systematically wrong. Okay? And the key word here with biased is that even with infinite data, you would still get the wrong answer. What about multicollinearity? When does multicollinearity happen? Multicollinearity happens when included variables are highly correlated with each other. Okay? And the end result of this, the consequence of this, is that actually the coefficient is imprecise. So your model is correctly specified, all the variables are included, but it is hard to separate their individual effects, okay? And here the keyword is on, or the emphasis is on imprecise, because what that means is, well, with more data, the problem actually gets better, which is the opposite of omitted variable bias, okay? So if we were to make a very quick summary of what the problem is, so we've got OVB and multicollinearity. If we talk about whether you have a bias estimate or not, and here the answer for OVB, or let's say unbiased instead, so that it makes it more intuitive, we put an X, so yes, it's going to actually be biased, so not unbiased. What about multicollinearity? Is it going to be biased? No, really, so we should be okay here. And let's just do this because that makes more sense. So yes, it's going to be biased. No, not biased. What about precision? Is it going to be precise? Can be with OVB. However, multicollinearity, no. And the last one, more data helps. The answer for OVB, nope. It doesn't matter how much data you add, it's still not going to make the problem go away. However, multicollinearity, yes. Okay, so OVB clearly affects accuracy. You are aiming at the wrong target. Multicollinearity affects precision. You are aiming at the right target, but let's say your hand is shaking. The more data helps column in here is quite crucial. So keep in mind that multicollinearity is a data problem. More observations reduce standard errors, while omitted variable bias is a model problem. So no amount of data will fix the fact that you are missing an important variable in your model. Okay. So OVB, also think of it as OVB, as a specification problem, while multicollinearity is an information problem. Okay. Let's come up with an actual example to give a little bit more perspective to you guys so you understand when do you have OVB and where do you have omitted variable bias. So in the typical example that we've used in the previous videos as well, when you omit ability from a wage regression, it's education that absorbs the abilities effect, which means that the beta of education is going to be overestimated even if you have 1 million observations. Multicollinearity, on the other side, let's say you would have included both education and experience in a wage regression. Both are positively correlated. It's very hard to tell which one is driving income, whether it's like more education or experience. So ultimately, you'll see beta coefficients that have also large standard errors. Beta 1, though, in front of education in this case, is going to be unbiased. Some data sets, so even if you have the same data sets, the same variables, one is a specification error and the other is just like noisy estimation at best. Even with perfect multicollinearity approaching, variables, meaning like where variables are almost identical, as long as all relevant variables are included, the coefficients are still unbiased. So OLS is still finding the right answer on average. It's just doing so with a lot of uncertainty. Okay. This is why the solution most of the times to multicollinearity is never drop a variable unless you are sure that it's irrelevant. Dropping a correlated but relevant variables then means that you are trading precision, a precision problem for a bias problem, which actually would give you a much worse outcome. Okay. Omitted variable bias is dangerous because it gives you the wrong answer, and no amount of data, no fancy standard errors or robustness checks will be able to fix it. The only solution is you including the omitted variable that was causing the problem overall. In a dissertation context, for instance, if someone says that your results might be due to omitted variable bias, that's quite a serious concern. But if they say that you have multicollinearity, that means it's manageable, and you just have to make sure that you include a bit of that conversation into your methodology part. The one sentence key takeaway of this video is that omitted variable bias makes your estimates wrong. Multicollinearity, different problem, just makes them imprecise. And only one of these two can be fixed with more data, and that is multicollinearity. I hope this was helpful, and I'll see you in the next video.